All right, we're going to do a worksheet on neutralization and titration. This should be familiar to you because we did this formula, which is the MAVA formula, or MAVA. Let's get rid of that. MAVA equals MVVB formula that you're going to find on table T. Okay, given the word equation for a neutralization reaction, an acid plus the base yields salt and water. That's true for every neutralization reaction. These are types of double replacement reactions. So question number 2 here says, how complete these equations. So if it's a double replacement reaction, remember we're going to take the outers with the outers. In this case, we're going to have H going with OH. That's going to be my water. And my salt is going to be my Li and my Cl. Don't forget to put your charges in, cross them down. Same thing for this next one. HNO3, which is nitric acid. You can find the name of that on table K. And CSOH, which is cesium hydroxide. So we're going to take the outers, which are going to be H and the OH, your water. And we're going to take the CS from the cesium here and the nitrate from the nitric acid. We're going to put the +1 for the cesium, the -1 for the nitrate. We're going to cross them down. There's my water. There's my salt. All right, HBr and KOH. That's hydrobromic acid and potassium hydroxide. HOH plus K and Br. +1, -1, cross them down. Nice and easy. Okay, number 3. A blank is a laboratory method used to determine the concentration of an acid or a base in a solution by performing a blank reaction with the standard solution. So we're going to say a titration reaction. Titration is a laboratory method used to determine the concentration of an acid or a base in a solution by performing a neutralization reaction. Okay. Titration is the name of the process that we're going to do, and I'm going to show you that in class. And a neutralization reaction is the reaction that's taking place. At the end point of the titration, an indicator changes color. Once neutralized, the moles of H+, which is the same as saying H3O+, and the moles of OH are going to be equal to each other. If you have equal numbers of H+ and OH, you will essentially have water, which is neutral. Okay, now let's do some titration questions. Remember, whenever you see the word titration, dilution, neutralization, it's always this MAVA equals MVVB formula. So the first thing I do is I write that down. We're taking HClO4, and NaOH. And if you want to write the products, you can. Of course, it's going to be water, because water is always one of your products. And we're going to have Na and ClO4. 20 milliliters of a 5 molar HClO4. 20 milliliters is my volume. 20 milliliters is my volume, and 5 molar is my molarity. What is the molarity of the base? This is the base. Be sure to write the neutralization reaction. Okay, I skipped this part. It's 100 milliliters of the base. It's up here. Okay, 5 times 20 is 100, equals 100x. So x equals 1 molar sodium hydroxide. All right, let me see. Can I go up on this page? No. In a titration of HNO3, that's my acid, nitric acid, and sodium hydroxide, 60 milliliters of 0.2 molar NaOH. So these are my bases. This is the base stuff. Okay? It said titration, so I'm going to write my formula down. MA, molarity of my acid, is what I'm looking for. The molarity of the acid. The volume of my acid is 15 milliliters. That's my acid. The molarity of my base is 0.02. And the volume of my base is 60 milliliters. Alright, we're going to need a calculator for this one. Grab a calculator. 60 times 0.02 is going to be 1.2, and I'm going to have 15x, and I'm going to divide both sides by 15, and I'm going to get x equals 0.08 molar of the acid, which is HNO3. Okay, number 7. If 10 milliliters of a 0.3 molar potassium hydroxide are required to neutralize 30 milliliters of stomach acid, what is the molarity of the stomach acid? Alright, it said neutralize, so I write my formula down. B. The molarity of my acid is going to be my X. It says what is the molarity of the stomach acid? The volume of my acid is 30 milliliters. The molarity of my base, the base, is 0.3, and the volume is 10 milliliters. Okay, 10 times 0.3 is going to be 3, and then I'm going to divide that by 30. And I'm going to end up with X equals 0.1 molar stomach acid, and they tell us stomach acid is hydrochloric acid, so that's my answer. Alright, last one. How many milliliters of 0.22 molar cesium hydroxide solution is needed to neutralize? Neutralize my keyword, write my formula down. 26.4 milliliters of a 0.25 molar HBr. This is my acid. Okay, so my molarity of my acid is 0.25. The volume of my acid is 26.4. The molarity of my base is 0.22. That's 0.22 molar of my base, and I want to know the volume. Now it's just a matter of doing math. What's 0.25 times 26.4? It's going to give me 6.6 equals 0.22x. And I'm going to get x equals 30 milliliters. And I should probably label that CSOH, cesium hydroxide. Okay?